8D is solving a radical equation. So you see the four steps here. These are 4 steps to follow for solving all radical equations. First is isolate the radical. So that's getting that radical all by itself. Then step 2 is to raise both sides of the equation to a power that is the same as the index of the radical. This is just, if it's a square root, you raise it to the second power. So square root and square are opposites. If it's a cube root, starts off as a cube root, you will be raising the whole problem to the third power. Fourth root, raise to the fourth power. And once you get rid of the radical, you solve the resultant equation. You just solve it like you did in Algebra 1. And then you check for extraneous solutions. You have to check for extraneous solutions. This is not a checking your work. This is part of the actual problem. You have to check to see if the mathematical solution that you found is an actual solution. So, and you actually, I'll talk about it later. Example 1, we have, here's the radical, the cube root, and you're subtracting 4 from the cube root here. So first thing you do, isolate the radical. And you have a cube root, 4x minus 8, and equals 4. Now this is step 2. The radical is isolated. You need to raise the radical to the index, cube root, so you raise it to the third. Do that to both sides of the equation. Cube root and cube cancel out. So you have 4x equals 8 and equals 64. And now it's just a 2-step equation. Add 8. 4x equals 72. Divide by 4. You get x equals 18. For the quick check, wow, that is sloppy. That says check. You have the cube root, 4 times 18 minus 8, and subtract 4 on the outside, that has to equal 0. So we have cube root, 4 times 18 is 72, minus 8 is 64. So cube root of 64 is 4. And 0 does equal 0. So it's good. So x equals 18 is the solution. And to be honest with you, they're always, all solutions are good unless you use the unless you have a quadratic. So you really don't need to check unless you have a quadratic. Second problem. We have, see, here you have multiply by 3 on the outside and subtract 9. So do the reverse order of operations. So add 9. Add 9. So you have 3 times the square root of 2x minus 1 equals 6. Divide by 3. And you get, now the radical is alone. And so now it's a square root, so the opposite of square root is square. And down to a 2-step equation. 2x equals 5 divided by 2. So we didn't do anything with a quadratic here, so you technically do not have to check it. It's going to be a solution. If you ever have a quadratic at any point in the problem, you're going to have to check to make sure it is a real solution. All right, example 3. So here we have variables on both sides of the equation. The absolute, or the radical is already isolated, so we're past step 1. Step 2 is to do the opposite of the index. It's the square root, so square it. You have to square the whole right side. This gives us another little type of problem on the right side here. So left side, square root and square cancel out. That's nice. But then we have x plus 1 squared. Binomial squared means that times itself. So we have to do x plus 1 times x plus 1. We multiply that out. X times x times 1. 1 times x and 1 times 1. That will give us x squared plus 2x plus 1. And on the left side you have 5 minus x. Well, I see a quadratic, so let's put all of our terms to one side. The a in the quadratic right now is positive, so I'm going to move all the terms to that side. You don't have to have the a positive, but keeping the a positive in a quadratic is less confusing in the end when you use the quadratic formula or when you're factoring. 3x minus 4. So at this point, once it's equal to 0, you have a quadratic equation here. You can do the quadratic formula, so your a is 1, your b is 3, and your c is negative 4. You can solve that way. Or sometimes there's a shortcut. And I see the shortcut. If the a is 1, you can do what two numbers multiply to negative 4, the c, that'll add up to 3, the b. And that is, so what I'm doing here is I'm factoring. So x plus 4, x minus 1. The reason why I'm going to factor is the left side is equal to 0, and factors mean multiplication. So two things that are multiplied together to give me that. So if you set each factor equal to 0, both of those will give me solutions to the problem. So the first solution is x equals negative 4. So if I put negative 4 back into this equation that's factored, negative 4 plus 4 is 0. Negative 4 minus 1 is negative 5. 0 times negative 5 is 0. So this is one of my solutions. Again, we do have to check it because we have a quadratic. Then we have plus 1. So my other solution is 1. Let's check them. I don't need to see the check written out like this, but sometimes writing it out is the best way to do it. So 5 minus negative 4, that's substituted in. Always go back to the original problem to substitute in. Parentheses around that. Don't have to, but when I substitute, I like parentheses around stuff. So 5 minus negative 4 is 9. Negative 4 plus 1 is negative 3. Square root of 9 is 3. Does that equal negative 3? No. So negative 4, that is an extraneous solution. So it's not a solution. You can just cross it out. You don't have to write extraneous, but it's definitely you have to cross it out or write extraneous or something. Signify that it is not a solution. Put 1 in, so check 1. So 5 minus 1 equals 1 plus 1. 5 minus 1 is 4. Square root of 4 is 2. 2 equals 2. That's good. So x equals 1 is my solution, my only solution. Alright, on to the next problem. Example 4 looks tough because there's a square root on both sides, but they're both isolated, so we just move on to the next step. So you square both sides. And fortunately they both cancel out, so you just have x plus 4 equals 2x minus 13. Now you just put your like terms, get your like terms together. So minus x. I'm going to add 13 to the left side, put my variables on one side, my constant terms on the other. So 17 equals 1x, or just x. And I did not use a quadratic. I didn't have a quadratic anywhere, so this is a solution. And if you wanted, you could plug it back in. 17 plus 4 is 21, the square root of 21. 12, or 2 times 17 is 34, minus 13 is 21, so the square root of 21 equals the square root of 21. That's good. Alright, example 5. Alright, example 5. So this one, it's a fun problem. So you have to square it. It looks similar to the other problem, the last problem, but we have this pesky 1 over here, so it's not going to be as easy as the last problem. But we need to isolate a single radical. So it does not matter which one you isolate. I'm going to isolate the square root of 2x plus 3. So I'm going to subtract the square root of x plus 1. which is going to give me square root of 2x plus 3 equals 1 minus the square root of x plus 1. Now we have it isolated on the left side. Don't care that it's not on the right, I'm just isolating one of the radicals. Square it, square it. So we have on the left side, it's nice, 2x plus 3. And that's going to equal, it's binomial, it's two terms squared, so that's 1 minus the square root of x plus 1 times 1 minus the square root of x plus 1. So on the right side we have 1 times 1 is 1. 1 times the negative square root of x plus 1 is a negative square root of x plus 1. Negative square root of x plus 1 times 1 is another negative x square root of x plus 1. And negative square root of x times a negative square root of x is a positive square root of x plus 1 squared. Or you could just not have a square root right away. And on the left side we have 2x plus 3. Oh, that right, the left side's so much easier. So let's combine some like terms here. 1 minus, so here's our like terms. Radicals are the same underneath and the same index, square roots. So negative 2 square root of x, that's an x, plus 1. And square root and square cancel out, so plus x plus 1. Let's kind of combine some like terms here. So we're gonna subtract x to the left side, subtract 1, and I guess we can subtract another 1. You can follow that. Cancels, cancels, cancels. We get x plus 1 equals negative 2 square root. That's a funny looking x. Square root of x plus 1. So now we can divide by negative 2. Divide by negative 2. And then you have x plus 1 over negative 2 equals the square root of x plus 1. Now this radical is isolated. Square it. Square the left side. So when you're squaring a fraction, you square the numerator and you square the denominator. So I have x plus 1 squared. So that's x plus 1 times x plus 1. And then you have negative 2 squared, which is 4. Equals x plus 1. Alright, let's keep going. So I don't like this division here. I don't like fractions, so whenever I have them, I get rid of them. So I just multiply by the denominator. Multiplying by the denominator gets rid of the fraction. And I'm going to do x plus 1 times x plus 1. That's x squared plus 2x plus 1. That's going to equal, let's distribute this 4 in. 4x plus 4. Move your terms, all your like terms together. Again, the a is positive, so I'm going to keep this x squared over on the left side. And I'm going to move all the terms to that side. You always want to keep that a positive. It's just a lot easier to solve problems when a is positive. Alright, finally we got it equals 0. We have a quadratic, no other radicals. Awesome. You can use the quadratic formula, so it's 1, negative 2, and negative 3 is your a, b, and c. Because it's x squared, it's an easy one to factor. So we have x and x, and what two numbers multiply to negative 3? That adds up to negative 2, and that's negative 3 and 1. That only works when the a is 1. Otherwise you got to use the Punnett square or another way to factor. So now set each factor equal to 0 and solve. That'll be x equals 3, and set that other factor equals 0. That'll be x equals negative 1. Now we do have to check this, so let's check 3 all the way up. I'm going to put 3 in. To do 2 times 3 is 6, plus 3 is 9. The square root of 9 is 3, so this is 3 here. And then 3 plus 1 is 4. The square root of 4 is 2, so we have 3 plus 2 is 5. Shoot, that does not equal 1, so we already have an extraneous solution. So x equals 3, not a solution. That's extraneous. Let's substitute in -1. 2 times -1 is -2, plus 3 is 1. Square root of 1 is 1, so this is 1. -1 plus 1 is 0. Square root of 0 is 0. So we have 1 equals 1. That's good. So that's a quick check. So x equals -1 is your only solution. Moving on. Only other problem here. You have cube root. We hadn't touched one cube root since the beginning. This is very, very similar to example 3, I think it was, or 4. Radicals are all isolated, so you raise it to the third power. And so those cancel out. You can't solve problems with different indexes if they have different indexes, like if there's a square root and a cube root. Not in Algebra 2 Trig. In the future you can, just not now. You won't have that. So subtract 2x, add 2, 9 equals x. You can substitute back in. 2 times 9, 18 plus 7, 25, cube root of 25, and 3 times 9 is 27, minus 2 is 25, cube root of 25. That's good. I don't have to actually find that number, just cube root is good enough. Alright, come to class with any questions you have. Thank you for listening.